It's like they moved the scale and 0 wasn't where it's supposed to be anymore. Is that? And mathematically, if you put 0 where it should, division will then make sense. If 0 is not where it's supposed to be, then what the hell's twice 0? Mathematically, it's 0, but how the hell does that make sense? What's twice as hot as a 0 degree day? It ain't 0, right? It's 8,000 degree times as hot today. 0. No, doesn't make any sense. And you're all like, I can see some of you guys are like, ain't nothing making sense coming out your mouth. Please, you gotta get in there, you gotta try this stuff out. Okay.
Question.
Yes.
Can time be either interval or ratio?
Time is neat. Bless you.
Thank you.
If you say time as shown on that clock, I would say interval.
Interval.
Because then if it's 3 o'clock versus 12 o'clock, 3 divided by 12, what the hell's that mean? Well, what about a military clock?
But if it is
Military
like
time.
midnight, and
Say again? Where's the military time start? 0. And then it goes up to almost 24, right? 23, 15, whatever. You guys with me?
Yeah.
And then division would kind of make sense. It's twice as many hours. So 0 means the start of the day. The day has had no time go by yet.
Yeah.
So if I said military time, that would be ratio. If I say time as that clock says, is there even a 0 on it?
No.
And don't tell me 12 is like, no, it's 12. It's freaking 12, right? There's no 0 on it. So how could it mean what's supposed to? Maybe?
So our clock is what? If military ratio, our clock will be
Definitely would be interval, because how do we use time? He got here 2 hours before me. Interval. Subtraction makes sense. Yeah. I like it. Maybe. Okay. So there are some like that. You gotta be a little careful, but okay. All right. So, as I promised before, so 2 things I promised. First chapter is going to be boring as hell, and you can see that in action. Second thing is I want to go back and talk about sampling. We talked a little bit about why you guys were a bad sample. So let's talk about how you can pick good samples. All right? So types of sampling. I gotta keep an eye on the clock because I think about 8:30 we're gonna head out for a field trip. Roughly 8:30, we'll see. Okay. Nothing too exciting, I'm sorry. We're not gonna go to the Natural History Museum and see dinosaur bones, I'm sorry. So types of sampling. The most basic type, of course, is random. Every type except for one of them will all strive to be random. So the only time your answer to a type of sampling question will be random is if there's no other method used. So random would be put a bunch of names in a hat and pick one. There's no method there, really. So as I talk about the methods, you'll see what I mean by method. So random, and again, remind me, what was the point of random? It's trying to do what? Say again? Well, what's the goal to make something as random as possible? What is a random sample supposed to do the best? Represent a population. Why? Because every element, here we go, this is the official definition. You guys cool with the word element? Every element, thing or person, in the population has to have an equal chance to get into the sample. Let me write it down. Every element in the population must have an equal chance to get into the sample. That was one of the most fundamental problems with using you guys as a sample, is not everybody has to take stats. Not everybody can or wants to be here at 7. Some of you guys are like, I didn't want to, but you're here. Okay. You guys with me? Okay. So, what are some of the methods that try to get at this that actually have a little more system to them? Let's start there. There's one called systematic. This one is something like every nth thing. You guys ever heard that before? Every nth thing or interval or whatever. So if I said every 8 minutes, I go out and take the temperature. I've collected a sample of temperatures using the systematic method. Every 12 feet, I collect grass. And then I'm going to go sample it and see what the hell's going on with the grass. Every nth something. That's systematic. Okay, I like it. Okay. Bam. Then the next two I'm going to say together here, we got stratified and cluster. These kind of go together because these are going to suck. These are going to suck for you. They start with the same, yes?
Is it also going to be considered like qualitative and quantitative?
No. This is just how to collect samples. So they're not talking about what you do with the samples. They're not talking about any data at all. This is just how do you even get a sample in the first place. So I could pick a sample using the systematic method, but then what do? I couldn't calculate an average. I could calculate a percentage. I could do all kinds of shit with it. So this doesn't care what you're going to do. Just as cares how do you get the things you're going to do something to. With me a little bit? So aliens come and take every 7th cow. So that would be systematic, right? I'm on to them. I know it's every 7th.
The
7th cow of a 7th cow. So both of these have the same first step, which is really kind of evil. They break the population up into groups. Let's just say I got 3 groups. Break, pop into groups. So same thing here. Break, pop into groups. Okay. Everybody got that? So for example, if I said I'm gonna look at all the zip codes, all those that's it, yeah. Which one do I want to use? Yeah, zip codes. And then let's say, so that's how I break the population up, is all this each zip code. Or I could say each classroom on campus. Now watch. So that could be either one so far. Stratified takes some from all. So if it was the classrooms, if I took 5 students from every classroom on campus right now, that would be stratified. Now to be honest, it's got some issues because not every student from Grossmont is here right now. But still, right? If I broke everybody up in the classrooms and took 5 from each, that's trying to be stratified. Stratified is some from all. Some from all. What's the first letter in stratified?
S.
What's the first letter in the little thing? S. All right. Sounds a little bit like 3 Musketeers, but for some and some. Okay. Cluster, and I love the word cluster. What do you guys think when I say cluster? Some of you guys might finish it off with a bad word. All right. That's all right. There it is. But weirdly enough, when I hear cluster, I think about cereal, the honey nut cluster business. So when you get a cluster, you take the whole damn thing, right? So cluster would break the population up into groups, but then it would take everybody from some, all from some. All from some to be the sample. So if I broke the college into classes and it took everybody from 5 of those classes, that's cluster. Why are those both still random? No. What does random have to do? It has to allow what? Every element in the population must have an equal chance to get in the sample. Some people argue right here, they're like, well, these people didn't have a chance. Yeah, they did. Of course they did. How did I pick those 2 randomly? Could I have picked this one? Yes. Was there anybody in the population that could not get in the sample? No. So don't look after I've picked. Of course there's people that couldn't get in the sample. So you guys, I could break you up by rows, right? So if I took everybody from this row and everybody from the first row, what method did I just use?
You used cluster.
Cluster, right?
Yeah.
All from some. Did everybody have a chance? Yes, because I could have picked a different row. Nobody was left out. My population is everybody here right now, right? In case you're curious. Okay. You guys a little bit with me? So those kind of suck because they're very similar. Some from all stratified, all from some the other one. Plus. And then of course you got this guy. I'm going to put him off by himself because he sucks. Convenience. And that's what you guys were, of course. I'm not saying you guys suck. I'm just saying you were convenient. I didn't even try to make it random. If I just take you guys as my sample. I didn't even try to make it random. So that one, if it's anything like convenience, maybe you're a beautiful sample. Maybe you represent the college perfectly. But I have to throw this shit out because I didn't even try to make that happen. I'm just trying to get lucky. That's crazy. Maybe? Maybe. Okay. Those aren't too bad, right? Not yet. Okay. So again, you got to try those problems out in the book. Okay. All right.
So
Yes.
from the types of sampling, like convenience would be considered a bad sample, right?
Mm-hmm.
But all the other ones, depending of their like research or whatever they're trying to figure out, they can classify it's good.
Yes. As long as you randomly, every step that's supposed to be random. Now here, systematic, for example.
Yeah.
The random thing with that, if I wanted to take every third student, the random thing is which student do I start with?
Yeah.
So randomly pick a student to start with, and then I do every third. Did everybody have a chance to get in the sample? Yes, because I could have picked a different. So if I start with you, one, two, you, and you're like, you didn't have a chance. You're looking at it after I picked. I'm not going to take everybody. That's the whole point. If I picked a different starting person, is there anybody I would leave out? No. Everybody would have a chance. Do you guys get that?
Yeah.
Don't say they didn't make it in the sample. Of course they didn't. That's what a sample is. Sample's not everybody. I can't work with everybody. Shit. I want a smaller group to work with. But did everybody have a chance to get in? Okay, I like it.
So convenience is not random.
Yes, we have to assume it isn't.
Okay.
It could just by chance be random. It could just by chance be the best possible sample, but how the hell would we know? And that's the really neat thing about statistics is, well, not neat, it's the evil thing. You very often, you don't know what the real answer is, and you never will. Because we'll take a sample from somewhere. So if I want to know how good the water is somewhere, then I analyze every water droplet out of a river. No, so I have to take samples. Will I ever actually know the actual full truth? Nope, that's life. What I love about statistics, it's the most honest. Because it'll say shit like, yeah, 20% contaminants, plus or minus 7%. You know, it's like, well, you know, it's pretty good for government work, right? You guys kind of with me a little bit? And that's why people kind of hate it. But without it, you got my little brother. I was going to do this, but he's actually taller than me. And he still says this. I loved him. He said, do you teach probability in that class? And I'm like, yeah. He's like, everything's 50-50, dude. It's going to happen or it ain't. And I'm like, Jim, don't become a doctor. Right? What's my chances, doc? 50-50. Whoa! You know, it's like, no, I want to know, is it 90%? Is it 2% chance I'm going to survive, right? Yeah. That means something. Does it mean something on a single time? Like 50% chance to get a tails. For a single flip, it don't mean shit. But over the long run, it means something. So, of course, if I'm told 98% chance you're going to survive, my brain, of course, is going to go, 2% chance I'm dead. Oh, shit. Right?
Yeah.
But I'd rather, you know, if they say 72% chance you're going to survive, okay, now I'm going to worry some more. I'm going to try to learn more. I'm going to see what I can do to make my chances improve. You guys kind of with me?
Yeah.
Okay, so statistics has its place. It's just so often misinterpreted. Right? Okay, I like it. One thing I want to say about cluster real quick. One semester, a student said, cluster's bullshit, Jeff. Cluster's crap. He was really upset too. I'm like, dude, all right, you got to tell me what happened to you. So he was in the military, and they had sent in, it was soon after the fall of Baghdad, right after they went into Iraq. And they were sending in surveyors to check out the neighborhoods to see how safe the neighborhoods were. And they did a cluster. They had zones in Iraq that they had broken up into, and they were going to pick some to go check. So what these surveyors did, they were civilians. They said, well, that's a really bad place. Let's not go there. Let's go here and here. You guys kind of with me? Mm-hmm. So did that place have a chance to get, and it wasn't just that place, it was several, but did they have a chance to be in the sample? No. Would their results be skewed?
Yes.
Of course, automatically it's going to skew in the direction of things are better than they actually are.
Yeah.
So I'm like, dude, you are not right. Cluster is fine, they just didn't use it correctly, right? They directly used it bad. You guys kind of with me? So every single one of these could be misused, except for him, you can't use him right. But if you use these correctly, they will always be something I can trust. Will they always be actually good samples? No. If I took a sample of 300 Grossmont students to figure out average age, could I randomly get people that are way younger?
Yeah.
Yes, it could happen. But if I do it with every intention trying to make it representative, I can't mistrust what I see. Maybe? Okay, maybe. All right. Anything else about this stuff here? All right, you got to try them out so you can see how they feel or how they go. Okay. Time to go. Good. All right. So far we've gotten through section 1, 2. 1-3 is kind of nice because it leads right into chapter 2. And I'll tell you this right now. Sometimes I don't even say this, but I want to try being nice. I want to see what it feels like. Section 1-4, I'm not even going to talk about because I'm an asshole. You got to read section 1-4, right? And then do the 1-4 homework. You guys with me? Just kind of want to remind you at the outset that the class isn't just made up by what I say. It's made up by what I say and what the book says. I'm not going to do that again. But 1-4 is your thing to do and ask questions about. Okay. 1-3 gets into these things. Frequency tables or frequency distributions. So, let me do this. What this is trying to end up, well, let's do it this way. Let me do it this way. Let me just get your reaction to this. Right? 10 to 14, 15, 19, 20. Right? So far, this makes sense. Maybe this is ages of people at a bus stop. I don't know. Okay. All right. So can somebody just tell me what 7 might mean? Yes.
Is it 7 people that are, is that ages?
Yes.
Well, 7 people that are, their ages is between 10 and 14.
Yes, cool, right? So that's all a frequency table is it's like a tally. So you have a bunch of people, how old are you? 7, how old are you? Well, not 7. 10, how old are you? 15, how old are you? 12. And then you just say there's 7 people between 10 and 14. And then there's 11 people between 15 and 9. So somebody else tell me, how many people did I talk to?
We like add all the
Yeah, you add all the
frequencies and then
frequencies.
it will tell us.
Yeah, right? How many total people did I talk to? 40. I like it. How are we doing so far? Nothing amazing here, right? This is kind of silly. The hard part, or the harder part, it's not going to be hard, is when we have to make our own classes like this. These are called classes. I like it. So, can somebody help me out? Well, we invented everything to do with numbers, except for the fact that the idea of what a number represents. But we created something a little bit easier to handle, which is percentages. Humans kind of latch onto percentages easier than anything else. So if I said 0.003, do this, you're like, what the hell? If I say 0.3%, you're like, okay, very small percentage, less than 1%, I can kind of understand what it means. How would I make percentages out of these? And this is something we call relative frequency. Real freak. So you can see, maybe you can see why it's called relative frequency. How do you make the percentage for this first class? What percentage of the people are in this first class?
Do you divide 7 by 40?
You do, right? And that's why it's called relative frequency, because it's the frequency for the class relative to the total amount. So there's 7 out of 40 people, right? 7 out of 40 people in this first one. Let's see, which is 2 times 5, 17.5%, I think, if anybody has a calculator. That might be right. Yeah, that's right.
Yeah.
Right, and then you keep going. 11 out of 40, I think it's 27.5, right? Is that right?
Yeah.
Haha. Sorry, I got it. It's my one skill. I got to show it off. You guys with me? Is everybody with me? This is nothing amazing. You've all done similar things to this. It's just the names you got to get used to. So frequency, it's how frequently does a data point show up in this class. Relative frequency is those relative to the total. Just percentages. So 14 out of 40, I don't know. I think that's 34.
35.
35? Yeah.
1.35 to 35%.
And then 2 out of 40,
5%.
5%. And then 6 out of 40 is good old 15%.
15.
And of course, in this case, what do all those percentages have to add up to be?
100.
100%. Right? Why sometimes would it add up to be not quite 100%? If you did everything right. Now, if it added up to be 92%, you missed somebody, right? But if it added up to be 99.8%, why is that probably okay? What did we not have to do here because the denominator was a nice whole number? I didn't have to round. But if you have to round, you might have to round up more than down. So maybe it comes out to 100.1%. Or not, if you might the other way, 99.8%, you know? You guys with me? But it should be close to 100 because that means you got everybody. Right? Maybe? Okay. All right. Most of you guys are still awake. This is good. Okay. So, I want to show you what we can... Let me do this. This is kind of... I like this. I've never actually done it this way. So before we talk about how these classes are created, let's try to do the next step. I'm going to kind of bleed into chapter 2. Right. Oh yeah, I got plenty of time. Ha ha. Sorry. Maybe we'll head out of here early. So chapter 2, the very first part of chapter 2 is about something called histograms. So you guys have seen, let me contrast this with bar graphs. Everybody in here has seen a bar graph. Something like, so here's a bar graph. Here's the one we're not going to really deal with. Bar graph looks like this. Men, women, right? And the amount of money they make or something. All right, so you can all feel as you want to about that, but unfortunately that's reality for a lot of things, right? You guys with me? Now, of course, that sucks because they don't have labels on their shit, right, or scale. But just to give you an idea, that's the shape of a bar graph. What kind of data is on this axis? Oh boy. Which one of the Q's? Which one of the Q's? Is it quantitative data or qualitative data? Qualitative. Men, women, right? Why did I put men first? Because I'm a man. I'm an asshole. No, I just did it alphabetically. Do they have to be in a certain order? No. right? So that you could even go say they're nominal, but really they're qualitative. Are you guys semi with me? So if you see a graph with like the number of cars sold, BMW, I always go for BMW and Hyundai, I have no idea why, and then Chevy, whatever the shit, right? Bam, 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 right? I mean, that's bar graph. See how they have gaps? Because the gaps don't mean you're missing anybody, because the scale isn't like a real scale. It's just names. Histograms are specifically for quantitative data, which is what this is. Ages are definitely quantitative, right? Yeah, yes? You guys all right? All right. Some of you guys' eyes are open, but I think you might have shut down, but stay with me now. So, histogram, now let's see. Now watch this. Couple things. You're going to love this. You really are. This is the way the book does it. I am going to show you a different way to do it so you don't have to worry what I'm about to do. But most people seem to like this way, so you're going to have to worry about what I'm about to do. If I put them up there the way they are, will there be gaps? Of course there will, right? If I did 10 to 14, where's the next class start? 15. So isn't there going to be a gap right there?
Yeah.
Okay. And what should a gap mean if I have a continuous scale? What should a gap mean? It should mean that there's nothing in that class. That should mean there's nothing there. So there cannot be gaps unless I had a 0 somewhere. Does that make sense? Why were the gaps here? Okay, because it's not a real scale. Right? I'm not going, you miss people. No, right? Okay. Maybe. Okay. So watch. Here's what you do. If you do this way, let me do this very silly thing. So, all right. There's a limit to me, right? I stop like right here. That's the end of Jeff. You with me? So that's my limit. But don't I have a boundary that you better not step in unless I know you, right? You with me? Step off. So these classes have limits, but then they also have what's known as boundaries. So if I go down by a half, up by a half, you see that? So what happens if I go down by a half here? See how these now are going to line up? There's not going to be any gaps. Maybe. So if you do it this way, you're going to have to deal with doing that on your scale. So it's going to be 9.5. What was it? 14.5. And then just keep adding 5. 19.5. 23.5. Blah, blah, blah. What's the scale going to be? Well, I haven't told you yet. I could either ask you to make a frequency histogram, or I can ask you to make a relative frequency histogram. What I normally like to do is to make you make a relative frequency histogram. So I want this to be relative frequency. And this would be, what was it, ages at a bus stop. Is that what it was? There's got to be 2 S's, Jeff. They can't read it anyway. That's a good point. So what should my scale be? Why do I not want to go up to 100%?
Because you don't have 100.
I don't have 100. And if I go up to 100, all this shit's going to be down here. It's going to look like this. I can't see anything. I can't see that. So maybe I want to go up how high?
40.
Yeah, or even 35. Maybe I can go by how many's? 5s, right? 5, 10, 15, 20, 25, 30, 35. One of the biggest, most important things about making graphs, which you're going to do a lot in chapter 2, is the scale has to be consistent. I love this student that says 10, 15, 16, 29, 34. All my pictures look the same. Of course they do, man. Your scale's got to show something. You can't just put them however you want to. You're going to lie to people. How are we doing so far? I mean, if you've graphed anything in your whole life in math, you know this. The scale's got to be consistent or else the picture ain't going to look right. So how tall is that first bar? 17.5. Kick ass. roughly about right there. And then the next bar is 27.5. And then the next bar is 35. And so forth. I mean, the rest, same way, right? You with me? So the hard parts about histograms are creating these classes in the first place. Remembering this shit. And then remembering to label. Right? That seems to be the hard parts. Okay. So here's the last thing we're going to do today. Is we're going to talk about how to create those classes and all that kind of business. Oh, before I do that, let me show you. What's the alternate way to write this? Here's the alternate way to write this. Now, some of you guys might see why some people don't like to do it this way. The other way to write this is to say, oh shit. Oh shit. What dumbasses. All right. Ooh, your car goes neat. Pretty much. So here, where does 15 go here? Obviously it goes here, right? Where's 15 go between these two? Same place, right? Because what does this say? Is this one allowed to equal 15? No. So if you don't want to remember inequalities and stuff, which is not the best sign in the world, but you don't have to do it this way if you don't want to. But what's my scale going to look like? 10, 15, 28, 25, haha, right? So the definite immediate impact of this is it makes the scale easier for your graph. Yes?
Just, so why is there a greater than or equal to sign in between the 10 and the x, but not between the x and the 15?
Oh, no, there isn't. What's happening? This is 10 less than or equal to x, right?
Yeah.
So x can go down as far as 10, but not all the way up to 15.
Oh, I
So
see.
the other thing this one sucks about is, what if my data had 14.6 in it? Where does 14.6 go?
Yeah, I see.
But here, it goes up there. So this method cannot handle data with decimals. So you'd have to actually make this have decimals, and that gets disgusting. Whereas this can handle every decimal there is. Yes?
One more question. So what was the purpose of class boundaries again? You mentioned the class boundaries.
So that there wouldn't be these gaps.
Okay.
If I go up by half and down by half, they both match at 14.5.
And that's what makes the histogram have no space in between.
Because
the
a
little
space, if I see a space in a histogram,
boxes. It's a bar.
that tells me there was no data there.
Oh, okay.
And that would actually maybe not be true. I can't, so I shouldn't have any gaps unless any of these are zeros.
Okay.
That's the only gap I should see. Okay, maybe. How you guys doing? You all right? This isn't really hard, but it is very different, right? Which kind of makes it hard in its own way, but it's just takes some getting used to. So I know I'm talking a lot today, but on